Welcome to Galactic Secrets. In this episode, we'll be exploring one of the most fascinating and far-reaching theories in the scientific community, the panspermia theory. Did life on Earth actually come from space? Could the seeds of life be scattered throughout the cosmos, traveling on asteroids and comets, waiting to take root wherever they land? We'll dive deep into the types and variations of panspermia and how they may explain life's cosmic origins. Before we begin, make sure to subscribe to our channel, hit the notification bell so you never miss an episode, and share this video with your friends and family. Now, let's explore the vast universe and the science behind panspermia. What is panspermia? The panspermia theory suggests that life on Earth, or at least the building blocks of life, did not originate here. Instead, these building blocks were brought to Earth from outer space, carried by comets, asteroids, or interstellar dust. This concept challenges the Earth-centric view of life's origins, proposing that life could be a cosmic phenomenon, spread across the universe and seeded on planets like ours. A key aspect of this theory is the idea that space is full of organic compounds, the very ingredients necessary to start life. In fact, scientists have found amino acids, the building blocks of proteins and life, in meteorites that have fallen to Earth. For example, the Murchison meteorite, which fell in Australia in 1969, contained over 90 amino acids, sparking interest in the idea that extraterrestrial materials may have played a role in the origins of life on Earth. Historical background: the idea of life being distributed throughout the universe isn't new. In fact, it dates back to ancient Greece. The philosopher Anaxagoras speculated that the seeds of life were scattered across the cosmos. However, the panspermia theory gained scientific traction in the early 20th century when Svante Arrhenius, a Swedish scientist, introduced the idea of radiopanspermia, suggesting that microscopic life forms could travel between planets on light or radiation pressure from stars. Later, astronomer Fred Hoyle and astrobiologist Chandra Wickramasinghe took the idea further, proposing that comets and asteroids could carry life forms across space, delivering them to planets like Earth. Types and variations of panspermia: there are several variations of the panspermia theory, each with its own mechanisms for how life could be transferred through space. Radiopanspermia. This variation, introduced by Arrhenius, suggests that microscopic life, such as spores or bacteria, could be propelled through space by radiation pressure from stars. While space is hostile, with extreme temperatures, high radiation levels, and a vacuum environment, certain microorganisms, known as extremophiles, have shown the ability to survive in such conditions. This variation suggests that life could travel vast distances, riding on light waves and radiation streams. Lithopanspermia. This theory proposes that life could be transferred between planets via space debris. When large meteorites or asteroids collide with a planet, fragments of that planet can be ejected into space. If these fragments contain microbial life, they could eventually land on another planet, seeding it with life. Scientists have discovered Martian meteorites on Earth, raising the possibility that life could have traveled from Mars to Earth in this way. Lithopanspermia suggests that life doesn't just remain confined to its planet of origin but can spread through impact events. Ballistic panspermia. This is similar to lithopanspermia, but focuses on the idea that life, or prebiotic materials, could be ejected into space from one planet and make its way to another via meteorite impacts. For example, life on Earth may have originated on Mars and been carried here via space debris. Some scientists even believe early Mars may have been more habitable than early Earth, making this variation a compelling possibility. Directed panspermia. This idea takes things a step further. Directed panspermia suggests that life might not have spread through random cosmic events but was intentionally spread by advanced alien civilizations. The theory speculates that extraterrestrial life forms might have sent probes, or even engineered meteors, to deliver life to planets like Earth. While this remains highly speculative, it aligns with the growing curiosity about extraterrestrial intelligence and the possibility that we are not alone in the universe. Life's journey through space: is it possible? A crucial question for the panspermia theory is, how could life survive the extreme conditions of space? Space presents numerous challenges: intense radiation, extreme cold, and a vacuum environment, but certain organisms, known as extremophiles, have shown the ability to withstand these harsh conditions. For example, the tardigrade, also known as a water bear, is a microscopic organism capable of surviving extreme environments, including the vacuum of space. In experiments, tardigrades have been sent into space and returned to Earth alive, providing proof that life can survive these conditions. Additionally, evidence from Earth's history suggests that the planet has been bombarded by asteroids and comets during periods like the Late Heavy Bombardment. These events may have brought with them the materials, or even the microorganisms, necessary to start life on Earth. Modern evidence supporting panspermia. In recent years, the idea of panspermia has gained more scientific support, thanks to discoveries from space exploration missions. In 2014, the Rosetta spacecraft made an incredible discovery when it detected organic molecules on Comet 67P, Churyumov-Gerasimenko. These organic compounds are among the building blocks of life, adding credibility to the idea that comets could be vehicles for delivering life across the universe. Another piece of supporting evidence comes from the detection of organic molecules and amino acids in meteorites, interstellar dust, and on moons like Europa and Enceladus. The fact that these organic materials exist beyond Earth suggests that life, or at least the materials necessary for life, could be widespread in the cosmos. Lithopanspermia. The transfer of life between planets. One of the most widely considered forms of panspermia is lithopanspermia, which involves the transfer of life between planets via rocks ejected from one planet and landing on another. This theory has become particularly compelling with the discovery of Martian meteorites on Earth. These meteorites could contain microbial life or evidence that Mars once harbored life, raising the question of whether Earth's life could have come from our neighboring planet. Scientists believe that meteorites or space debris ejected from Mars could have traveled through space and landed on Earth during its early history. With Mars being a focal point in the search for life, the possibility of Mars to Earth transfer remains a subject of intense study. Panspermia's implications for the future of space exploration. If panspermia is true, it would radically change how we approach the search for life in the universe. Missions like NASA's Perseverance rover, which is currently exploring Mars, and future missions aiming to bring back samples from Mars or other moons, are designed to look for signs of past or present life. Discovering life elsewhere in the solar system would be groundbreaking and lend immense support to the panspermia theory. Moreover, the exploration of icy moons like Europa, with their subsurface oceans, might reveal environments where life could exist, further evidence of life's potential spread across the solar system. Conclusion. Life's cosmic journey. The panspermia theory challenges our Earth-centric views of the origin of life, suggesting that life might be a cosmic phenomenon rather than a strictly Earth-bound event. Whether life arrived here through radiopanspermia, lithopanspermia, or even directed panspermia, the idea that we may share cosmic ancestry with life forms on other planets opens up incredible possibilities. Thank you for joining us on this exciting journey through space and the mysteries of life's origins. If you enjoyed this episode, be sure to subscribe to Galactic Secrets, hit the notification bell, and share this video with your friends and family. Stay tuned as we continue to unravel the mysteries of the universe.